And what is gravitational microlensing? How can you use that to detect exoplanets?
That is an amazing technique that Einstein first put out there. We don't know if he ever thought it was doable, but the bottom line is that mass bends space.
Mm-hmm.
And so if there is a star, I want you to imagine for a moment that, well, let's do it with the Legos again. Let's say we have a background star, and let's say you're the telescope. The telescope is where you are. And we have a star and planet that you can't see them. They're just dark. They're too dim. But the background star is like a big giant star, so it's very bright. Where the background star is like in the center of near the center of our Milky Way galaxy. Now these lenses go by, mass bend space. So now what's happening is the star that has to be directly lined up. It's just random. They're passing by. Some of the rays from this star, instead of going to outer space, they're getting bent around. The rays wanted to go out there, but we're getting extra light coming our way because it hits that little distortion in space. And then they come towards you. So as this star and its planet go by, you don't never see them ever. But the background star brightens a little. So for a while, instead of looking like this, it looks like this. It's big. It looks brighter. And by the way it brightens and the shape and the duration, we can pick out planets that are there. Crazy, right?
So cool.
So cool. And we found like probably a few dozen exoplanets that way. And later this decade, so around 2027, a new telescope is going to launch, a NASA telescope called Roman. It's actually named after Nancy Grace Roman. And it will be doing a survey, and it will find thousands and thousands of microlens planets.
Wow, it's so cool.
But just one reason why most people haven't heard of microlensing is, when the planet and star, let's see, I lost my planet and star now. When these planet and star go by, you're never going to see them again because we can't see them. They're too dim. They're just brightening the background star. But the chance that they line up with another background star is pretty much zero. So a lot of people haven't heard of it or don't really talk about it because they feel like there's no value if we can never follow it up. But there is value. It's like doing a census. You're going to learn about all the types of planetary systems out there. And in fact, its highest value in my mind is it will tell us how common planetary systems like our solar system are. So far, we have found no solar system copies.
This will just help you detect the planet, but it won't tell you much about the planet itself, or you can use microlensing to actually know some properties of the planet itself.
You can know the planet's mass, and sometimes you can know the planet's mass and something about its orbit, like how far it is from its star.